Hello everyone, I am Asif Shaafi along with my teammate Tingshuo Miao. We are from Baylor University and we are doing PhD in computer science. So today we are going to present our paper called Service Availability Ratio or SAR in short, an availability metric for microservice system. So let's start. So first of all, microservice services are actually based on small services, which make the microservice system really flexible and scalable. A microservice system can have hundreds or thousands of services, and they can all work independently without depending on anything else. And but one service can also depend on like two or three services to make itself work. And keeping track of all the services in a microservice system, it is really hard using the traditional approaches. That's why we introduced the service availability ratio or SAR to help with the availability tracking. So service availability ratio or SAR is a novel metric to quantitatively measure the end-to-end service availability within the microservice system. This SAR actually uses the trace data to identify the current state of a microservice system, and it can also be used to determine the reliability and stability of the system. SAR, along with the problematic service availability ratio or PSAR and SAR threshold, can help the developers to get an overall idea of the current status of the system, and we will look into those in more details in upcoming slides. So, what actually motivated us to come up with the idea? The performance testing in microservice services using the traditional approach is really hard, as microservice can have hundreds or thousands of services, and they can be independent or dependent on each other. It can get really complex, and the execution environments and high variation in the test results can also uh, affect the traditional approach to get the performance and stability of the system. Each service has individual performance status, so detecting the small performance regression is really difficult, as there can be, as I said, hundreds of thousands of services in the system. So to solve that one, metric stating the availability status is really gonna help. And in a microservice system, the distributed tracing contains a lot of data for the microservice API calls. Using those trace calls can actually can be used to gauge the performance, and can also reduce the help use of external libraries or tools, as we already have the logs inside our services and they are already there. And so the our proposed SAR and PSAR actually uses those distributed logs to give a stability score of the microservice API calls. So from our idea and the motivation, we actually came up with some research questions that we are gonna try to answer at the end of the presentation. So the questions are: can SAR be utilized to automatically generate the evaluation metric using distributed tracing? The second one is: how can the meaning of SAR and PSAR be justified, and what do the scores actually mean? And the third one and the final one is: how can SAR and PSAR scores motivate the developers to modify the code and its structure? So before looking into the SAR and PSAR in more details, let's get interest. Let's introduce some terms that will actually help us to understand what's going on inside the test logs. So the first one is span. A span is a single unit of work carried out by a single service. That is, in a microservice system, each service can do some work, and those work can be found in a span. And span can have the name of the service, unique span ID, and some context data like what data it's receiving and what data it's sending. Those kind of things are embedded in span data. And the next thing is just trace data. A trace is basically all the data that's inside a request or API call. So basically, a trace is the it contains a list of spans where each span represents a service, and there can be multiple service in a single API call. So a trace can have multiple services. Like in the right hand image, you can see there are some blocks. So each block represents a span here, and the parent block, that's the trace. So the TSEY dashboard default, that's the parent of the trace, and it contains the other spans inside it, and those are also like the payment one, that's also a trace, and it also behaves as a span for the parent trace call. So now I will hand over to my teammate Tingshuo, and he will continue.
So hello, here is Tingshuo, and first, by calculating the SAR or PSAR that we have introduced before, we need to do the step which is called the dependency build. That we need to extract all those dependency, or in other words, we call it inter-service communication in the microservices system by using all those logs or trace right here. And for our trace generating step, that we use our benchmark system, but based on our some of the research limitation, we can modify manually modify some things in our log to make it more compatible. And in our code or in our program, we build a module which is called JSON processor to deal with all those trace, to like extract all those data from all those trace or the spans. And each of the trace there is a JSON file. That's why we're calling our module as a JSON processor. And we just put all those JSON files into the JSON processor, and it's just gonna introduce, or it's just gonna generate the output of our golden standard or what we want. So for here, down here, there are two pictures. On the left hand side, it's just one sample of our input data, which is a trace. And on the right hand side, it's showing one example of the span. And we can see that each span is gonna have its own ID. And down here, what we care about is the operation name. So like what we have talked about before, the UI dashboard default is our first service that we have been calling in the picture. And so just for example right here, this option name is the endpoint that we are actually calling at that moment. And a span can have a child like what we have mentioned before, and a parent, of course. So this is what we have. Next, continue what we are talking. So based on our running logs or running trace, we generate all those golden standard. And down here, we just have one example for a golden standard that has only one operation or one interaction chain. And for this interaction chain, we have the number of spans with 8. That means like there are total 8 services has been called in that operation chain or interaction chain. And number span with 400, like that means like how many endpoints or how many services has returned the level of 400 code with HTTP that in this operation call. And the child, of course, like those are the services has been called and the details of them for each span. So for SAR, for calculating the SAR, we have the formula on the right hand side, which is that number of spans of input divided by number of spans of golden standard. So the inputs, like once we call an API, it's gonna generate a trace, and we use that trace to compare with whatever is in the golden standard. And for this step, for calculating the SAR, we define the unavailable service as the service that has written code of 400 level. So that means like 400 code will be ignored in our input trace. And the order of those service calls, it does not matter. So it could be called, like we have like a communication maybe ABC, so ABCD and ACBD is also possible, and it's still okay. And in the nature of the microservice systems, one API call can cause different path, or we can say can cause a different interaction chains. Like we can have ABCD, or we can have, let's say A is the first call and D is the last call. So A is the first endpoint and D is the last endpoint. So we can also have A, C, E, D in that case, but those are both correct path or correct interaction chains. So what we're doing here is like we have to compare all those paths that's in the golden standard with our input, and it's of course that's gonna generate like multiple output in that case, but we are choosing the best one in what we have done in our approach. And the output will be a JSON format, and we will also through or notify the user or developer who's using our approach to say that there's an unusual path. That means like there is one service has been introduced in the input path or the input operation chain that's not in the golden standard or cannot be found in the golden standard. So next, we have this PSAR, which stands for the problematic service availability ratio. And for here's like we define our available service as returning any code that's not 400 level, but a service can also have a return 400 level. However, 400 level does not mean that service is down or is not available, but instead of like we can have some wrong format of inputs in that case. So we have to consider this as something else rather than just saying, okay, if a service is available, so we propose this piece right here. And generally speaking, we should keep a service always return to your level. That means like the service has no problem at all. But PSR, yeah, we still have to consider this case because developers, they do care about 400 level, and this is somehow possible in any environment. But that means what we doing calculating PSR is here, like we calculating how many 400 level service has been discovered in the input, and we compare like how many servers divided like how many servers has been called in our golden standard for that specific path. Also, we also proposed the SAR threshold right here to define if a SAR is good or bad. Well, our best threshold right here is 0.95, and we introduced two things to deal with how we can make this SAR threshold dynamic. So first thing is service ratio. That is like for one input, how many services has been called for that operation out of the total number of services in the system. And here we choose to use exponential function to deal with those service ratios that we can see down here. We use mass xp function in the Java with our input, which is negative of service ratio. So in the image it shows right here that we can see that this is our non-linear function that can how we understand right here is like if we have a service ratio is 1, that means all the services are being used or has been called in one operation. In other words, all the services have been called. That means like there is a highly chance a problem could be introduced in that operation, like 500 or 400 level or no matter what. So in this case, we will have like a large number, or we will have like our threshold be like lower than how we're supposed to have before. But we don't want to have like a less service ratio to also have like a large influence in the threshold. So that's why we have introduced those exponential function right here. And another input is called depth. So depth is like how many services has been called for a child, and child has called another services, and the child has called another service. That's what we call depth here. So we can see from like images before, this UI has multiple child, and the child, let's say this is a child, and the child has another child, and we can see here, we can say that the depth here is 2. So back to our slide. If the depth is 2, we just do minus of 0.02 right here, because for each depth we just gonna have detection of 0.01. And the minimum threshold right here is 0.7, but this could be manually changed or modified if based on the user of our approach or our tool. And down here is like more detailed threshold formula that's introduced as that our threshold equals to the base threshold times to the exponential value of our service ratio minus 0.01 times our D, which D stands for the depth right here, and SR stands for the service ratio. And back to our benchmark system, we are using this train ticket system, and this is one of the largest and most complex open source microservice system we can find as one publication paper. And this microservice system includes really lots of things, including 41 microservices related to business logic, and including like reservation or payment or the change or the user notification stuff. And by using this benchmark system, we have to use Kubernetes and with Docker. However, this system just want to mention here that this system has 22 representative fault cases that has been injected default. And another reason why that we choose to use this system is that this system has the default login tools, so that we do not have to go to the system or to make some code change or to have to inject some of the login tools into the system, but we can just use whatever has been used in the system itself. For here, we're just showing the results of our tools or our approach. So on the left hand side, the first picture is showing operation with SAR equals to 1, PSAR equal to 0. That means like no service has been returned 400 level code, and all service has been returned 200 level code in this operation. And threshold was 0.5 because we modify those at that point when we do our experiment. And down here, the SAR is still 1 because we still consider 400 level, but this is showing PSAR with 0.16. Means like zero-sum service has the value of 400 level return code, and this is our result of PSAR and SAR. And down here in this picture, we are showing the result of on-you path. So how are we gonna know what's on you? So we're just showing this result for the operation call, and those are all the interaction or all the endpoints or all the services have been called. And with those non-standard right here, we can see that the service or the controller has not been introduced in the golden standard, but in the input of our tools of our operation. However, we're showing right here like this is still successful, like all the service has been returned 200 level of code, and in that case we still consider this as a successful path, but we're just showing what's been different right here or what's been special in this case. And we're, of course, if there's like all the path is showing failure or like non-success, we're just only showing those on your path happens in all match right here. So now next time I'm just gonna turn into Shaafi to talk about the rest of presentation.
Yeah, so now that we have actually a clear understanding on how SAR and PSAR works and what do they actually mean, let's go back to the research questions that we started and try to answer them. So the first one was, can SAR be utilized to automatically generate the evaluation metric using the distributed tracing? And the answer is yes, it can. So by providing the input data into the JSON processor that we talked about before, we can get the desired output JSON file and JSON data, and we can use that data to compare with the golden standards and find out the SAR and PSAR value for each input. And this process can be made automatic by using the continuous input from the system logs, and we can automatically get the SAR and PSAR values as an output. So yeah, it can be automatically generated and evaluated. The second one is, how can the meaning of SAR and PSAR be justified, and what do the scores actually mean? So the SAR metric, it doesn't actually say if the system is good or bad itself, but when we use that one with a new version of SAR for the new version for the system or the previous version of the system, and we compare both SAR values, then we can say okay, this the new update might have a greater SAR value than the previous one. That means it's a good one, or it has the similar SAR value, so it's they are the same. There is no performance boost or anything like that. So that's how we can actually use the SAR value as a threshold for the measurement of how good or bad the next version or the updated version is. And along with the SAR threshold, we can also measure if a specific part of the code or a specific service is good or bad than the previous one. Then the last one is how can SAR and PSAR scores motivate developers to modify the code and its structure. As we said before, that the SAR itself is not a measurement of good or bad. It's more like a threshold or a benchmark system that can be used to determine if the updated version or the next version is any better than the previous one. And if we see that okay, the SAR score of the new version is less than the previous one, that means the developer can understand okay that there are some lackings in the new version and they can update their code accordingly. And also using the PSAR value, we can see if there are any errors in the code, and using that metric we can basically the developers can actually figure out if there are any errors in the new system and then try to solve them. So basically the SAR and PSAR both actually lay out a guide for the developers which they can follow and improve their system. So finally, in the conclusion, the SAR and PSAR both provides a holistic measure of system availability based on the services in the microservice system. Both of them provide the current availability status of the endpoints in the system. They don't actually give a direct measurement of good or bad, but they can give a benchmark which can be used to determine if the new version is good or bad. And the PSAR can be used to figure out if there are any HTTP 400 level error. So we are planning to work on these metrics to give a better result in the future, and we will try to we'll work on this one to have a better system or better understanding on how can we get more performance from the microservice systems. So finally, these are the reference that we used in the slides, and they can also be found in the paper. So that's all for today. Thank you everyone.